Application of the iTrace Visual Function Analyzer Phase 1, Beginner Level. The iTrace combines a wavefront aberrometer and a corneal topographer into one system. It doesn't just provide the standard data from these two devices, it also generates additional insights about visual function. For wavefront aberrations, it uses ray tracing technology to measure how light waves are distorted as they pass through the eye. For corneal topography, it relies on the conventional Placido disc method to map the surface shape of the cornea. By combining wavefront and topography data, the iTrace produces more comprehensive reports about overall visual quality. In most cases, we focus on the integrated, combined, report to guide our analysis. Preoperative Reports Part 1, DLI and Surgical Necessity. In the preoperative stage, we primarily analyze two key reports. Let's start with the first one, Preoperative Report I, which helps us decide whether cataract surgery is needed. The most important metric here is the Lens Dysfunction Index, or DLI. This is a score from 0 to 10, where a lower number indicates poorer lens function. For example, if the DLI is 2.3 as shown in the figure, that's considered very low, suggesting significant lens impairment. Here's how we use the DLI to guide decisions. If the DLI is greater than 5, the natural lens is still functioning relatively well, so cataract surgery may not be necessary at this stage. If the DLI is less than 5, we need to dig deeper. Specifically, we check the level of corneal higher-order aberrations, HOAS. When corneal HOAS are greater than 0.2, it means the cornea itself has significant optical issues, so we typically avoid premium, advanced, intraocular lenses. When corneal HOAS are less than 0.2, the cornea is in better condition, and premium lenses may be a suitable option. Keep in mind, the cutoff value of 5 for the DLI is only a general reference and should be interpreted in the context of the full clinical picture. Preoperative Reports Part 2, Premium IOL Selection Criteria. Now let's move to the second preoperative report, which helps us select the most appropriate premium intraocular lens, IOL, for the patient. Focus on the right side panel of this report, the Premium IOL Selection Criteria. When you zoom in, there are 4 key parameters to evaluate. First, corneal higher-order aberrations. Second, the alpha angle. Third, corneal astigmatism. And fourth, corneal spherical aberration measured at 6 mm. There are 3 common types of premium IOLs, aspheric, non-spherical, lenses, multifocal lenses, and toric, astigmatism-correcting, lenses. For multifocal IOLs, the ones designed to provide both distance and near vision, we focus on the alpha angle, as it influences how well the lens aligns with the patient's visual axis. For toric IOLs, which correct corneal astigmatism, the most critical factor is the actual measurement of corneal astigmatism itself. For aspheric IOLs, which aim to reduce spherical aberration and improve overall image quality, we look at the reported value of corneal spherical aberration at 6 mm. These 4 parameters help us match the patient's corneal characteristics with the right type of premium lens. Postoperative report analyzing aberrations and clinical sources. Now let's shift to the postoperative phase. At this stage, we primarily analyze a single report focused on wavefront aberrations. The first step is to check whether any ocular aberrations are present. If no significant aberrations are detected, the patient's visual quality is likely very good. If aberrations are present, the next step is to determine their origin. Are they coming from the cornea, or from within the eye itself? Different types of aberrations correspond to specific clinical issues, and understanding these connections helps us identify the root cause of any visual disturbances. For example, intraocular astigmatism, astigmatism inside the eye, is often caused by undercorrection, overcorrection, or an incorrectly aligned axis in a toric IOL. Intraocular coma, a type of off-axis aberration, is typically the result of the intraocular lens being decentered or tilted. If the iTrace shows high corneal astigmatism after surgery, it may simply be due to the eye not yet fully healed, a common issue called surgically induced astigmatism, especially in the early postoperative period. Corneal coma is often linked to issues like descente or laser ablation, from prior refractive surgery, or conditions such as keratoconus. High corneal spherical aberration is frequently caused by a small ablation zone, which is common in certain types of laser vision correction. Corneal trefoil, a specific type of higher-order aberration, may be associated with prior radial keratotomy, RK, surgery. Other aberrations follow similar logic. Each type points to a specific clinical cause. By matching the observed aberration to its likely source, we can quickly determine what went wrong and how to address it.